Hey class, this video is going to be on 6.2a, simplifying fractions. Just when you think we were done factoring, we're going to factor a little bit more. So we're going to simplify rational functions. Remember, rational functions are when we have two polynomials being divided by one another. So it comes back to being able to simplify regular fractions. We can apply the same concepts. So I know you know that 2 4 simplify to 1/2, but it simplifies because 2 and 4 have a common factor of 2. 2 times 1 is 2, and 2 times 2 is 4. And then 2 divided by 2 equals 1. That's why it simplifies to 1/2. So they have a common factor. All right, let's look at this one. 10 plus 5 is 15. And 15 divided by 5 is equal to 3. So that simplifies that way, as well as if you simplified it like this. 10 divided by 5 is 2, and 5 divided by 5 is 1, and 2 plus 1 is 3. So because both are terms on top are divisible by 5, you can simplify it to 2 plus 1, and that equals 3. You'll see we'll get the same answers. For 6x and 12, they both have a common factor of 6. 6x is 6 times x, and 12 is 6 times 2. And 6 divided by 6 is 1. So this will simplify to x over 2. In something like this, I think, okay, what do 30 and 18, what's the greatest common factor that they have in common? And I'm thinking that would be 6. So 30 is 6 times 5. And 18 is 6 times 3, and then x squared is x times x, and x cubed is x times x times x. So we can simplify 6 divided by 6 is 1, x divided by x is 1, and x divided by x is 1. So in the numerator we have 5 left, and in the denominator we have a 3x. So that's what that rational function would simplify to. Okay, looking at this one, x minus 3 over x. So we have to kind of come back to this idea. I could only simplify the 10 plus 5 divided by 5 to 2 plus 1 because both 10 and 5 in the numerator were both divisible by 5. In this example, only the x is divisible by x, but not the 3. And so this is already simplified. Same with the second example. 2x is connected, and you can't simplify it with this. These both cannot be simplified any further. Anymore. Versus this example where it's similar to the middle one, but I have a 2x minus 6. And in the top, 2x minus 6 is the same thing as 2 times x minus 3. And then on the bottom, I essentially have a 1 times an x minus 3, in which case I have 2x minus 3's. X minus 3 divided by x minus 3 equals 1. And so this simplifies to 2 over 1, or just 2. So thinking about those common factors, what do they have in common in the numerator and denominator? Because anything divided by itself equals 1. Sometimes we say it cancels. It's fine to say that as long as you understand it's being simplified to 1. Okay, here's where you need your factoring skills. So if you remember, x squared minus 4 is difference of perfect squares. So that can be factored to x plus 2 and x minus 2. And then in the denominator, we have a factor of x minus 2. So we have 2, x minus 2, so those are simplified to 1, or they cancel. You can think of this as a 1 left in the denominator, like 1 times x minus 2. So you get x plus 2 over 1, or it's just x plus 2 left. Okay, this one we have to factor the top. That's a trinomial. It's a simple trinomial where we just need factors of the last one that add up to the middle. So factors of 6 that add up to 5 would be 2 times 3. And it's just x squared, so we don't really need the box, but if that helps you visualize it, you have the x squared and the 6, and you have the 2x and the 3x, and you'll see it's just x times x, x times 2, and x times 3. So this factors to x plus 2 and x plus 3. And then the denominator is difference of perfect squares. So that's x minus 3 and x plus 3. In which case we have a factor of x plus 3 in the numerator and the denominator. So those reduce to 1. And then we're left with x plus 2 over x minus 3. And that does not simplify any further because they do not have any factors that are alike. Okay, in the numerator in example 4, in the first one, I can take out a 6, and I'd be left with an x minus 3. And in the denominator, I just have a 2 times an x. Now you can think of 6 as 2 times 3 times x minus 3 over 2x. And maybe you didn't have to do that step. You just knew that 6 divided by 2 simplifies to 3. And that'd be fine. But this just helps you see that that is in fact a common factor that they have. And so those reduce to 1. So on the top we are left with 3x minus 3's x, or you could write it out as 3x minus 9 over x. Either one. If you leave it in factored form, you for sure know that they do not multiply or do not simplify any further. Okay, the last one, again, you need to factor it. It's factors of 10 that add up to 7, be 2 times 5. It's just x squared, so you know it'll be x times x, and then it's going to be x plus 2 and x plus 5. And in the bottom, it's difference of perfect squares. Just be careful because it's the 5 comes first. It's going to be 5 plus x and 5 minus x, which if you reverse those, on top you get x plus 2 and x plus 5. If you want to write them with the x first, that's fine. The first one will be x plus 5. The second one would be negative x plus 5. So we do have to be careful when we reverse this because the x is negative. So an x plus 5 simplifies with an x plus 5. So then we're left with x plus 2 in the numerator and negative x plus 5 left in the denominator. And that's the gist of it. So we're going to be working more with simplifying as we multiply, divide, and add and subtract rational functions. But this was just to get you kind of introduction into what it looks like to find those common factors and simplify.